Okay, today we are going to continue our lesson number 10, talking about the vector diagram. Okay, here. Um, Vector is not only for force. Force is one of the vector, okay? Force is belongs to vector is because force we got magnitude and also direction. What is magnitude? For example, force is 10 Newton. This one is magnitude. Okay, the 10 Newton is actually magnitude plus unit. And then direction. So for the force, do we need to consider about the direction? Yes. To the left or to the right, okay, the effect will be different. And also weight also one type of force. Okay, weight is also one type of force which is pointing downward. So force actually is vector quantity. Okay, so vector diagram is not only for force, can be others vector also. Okay, but here we're using force as our example for our vector diagram. Okay, force of 20 Newton in the direction of 45 degree north of east. So boys and girls, you see we got direction. Okay, we got magnitude. So this force is under vector quantity. Okay, so we are going to draw it out. How we draw it out? First, you need to set your scale. Okay, suitable scale for you. Okay, so if let's say the space for you to answer is big, but you draw your diagram so small, that is not a good scale. So we're trying to draw as big as we can. Okay, so the bigger the diagram that you draw, actually you can minimize the error. Okay, so at here, for example, this one for 20 Newton, it using 1 cm to represent 5 Newton. Every 1 cm to represent 5 Newton. So 20 Newton, we draw 4 cm to represent it. Then how we measure 45 degree? Using protractor. So we need to using protractor. Okay. Then after that, you need to draw the directions to showing your vector direction. Okay. So this is the first step. Okay. So previously what we learned about the force, if they are in the same direction, okay, before that here, case 1, okay, case 1, if they are in parallel, force in parallel or whatever vector in parallel, okay, for example, this force, previously when we learned about chapter 2 of 3, we also learning what? Okay, force is, let's say, 10 Newton. Okay, so here also pushing with another 2 Newton. So what is your resultant force? This one is 12 Newton. This one easy. Without drawing vector diagram, we can know. Okay, if let's say they are opposite direction for the force, here is 10 Newton. So here is 2 Newton. What is your resultant force? Okay, actually it's 8 Newton. Previously, we learned about this, right? But today, if I ask you, if let's say these two forces, they are not in parallel anymore, can we using mathematics way to do calculation for the resultant force? Okay, so at here, this is what we are going to learn today. Okay, if let's say they are non-parallel vector, how we solve the question? Okay, so previously what we learned mathematic way is just parallel, easy. Same direction, we plus it together. Opposite direction, then we're using big force minus small force. This one, opposite direction, see? Okay, we're using big force minus small force. Settle. But if let's say they are non-parallel vector, today we got few methods to solve it. One of the method is called vector diagram. Okay, here. Boys and girls, let's say the box at here. Imagine this is you. One of the friends pulling you upward, another friends pulling you this direction, another one pulling you another direction, which is 90 degree at here. Which direction you will follow them? Will you follow the 3 Newton or will you follow the 4 Newton? My answer is you won't follow either one, but you will move in between them. When they're pulling you, you're moving in this direction. This is the force that you experience, which is called resultant force. So boys and girls, you see 3 Newton and 4 Newton, they are not parallel, they are 90 degree at here. Where is our resultant force? In between them. So this is our resultant force. Actually, the box will moving in this direction. Okay, so this is the force that we are going to find. Okay, so for the first method, this is the example I show you the answer. Okay, method 1, we need to draw the scale diagram. Okay, we need to keep adding arrows end to end. Okay, what does it mean? Okay, for example, at here, draw arrows end to end so that the end of the one arrow actually is the starting of the another one. For me, okay, I would like to say you remain one force, then you move another force. Remain one force, move another force. What does it mean? For example, I remain the horizontal 4 Newton. So here, this is my 4 Newton. One force followed by another one. So this one, by this point, I continue with another force. So how I decided the 3 Newton actually is I just moving this 3 Newton to here, to the right hand side. So I remain the 4 Newton. I move 3 Newton, continue after 4 Newton. Okay, one force followed by another force. Or this method later on we will tell. This method we can say that is tip to tail. Tip to tail. Okay, so at here the tip continue to the tail. So this is tip, this is the tail. Okay, tip to tail. Or I say one force, then continue by another force. Okay, so from here we understand how we arrange the force for these two 90-degree forces. So this one 90-degree forces. Then after that, we choose the scale that we want in order to give you a big triangle. As I mentioned just now, cannot too small. Okay, so for example at here because my space is also smaller, so I roughly set 1 cm represent 1 Newton. So 4 cm I draw 4 Newton, I draw 4 cm. 3 Newton I draw 3 cm. So at the end, if you print it out in the actual scales, you using a ruler and you measure, my drawing should be showing you 4 cm and 3 cm. So can you try measure? Okay, so this one is my starting of the force. Here is my ending of my force. What is my resultant force? My resultant force from starting to ending. This is my resultant force. So look at here. This resultant force actually is my red color here, resultant force. If you're using a ruler, you measure this line. You have found that this line giving you 5 cm. 5 cm actually represent that my resultant force is 5 Newton. Okay, so this is called scale diagram. Okay, maybe you say, teacher, just now you say you maintain one, then you move another force. Then why you maintain the 4 Newton? Can I maintain the 3 Newton? My answer is yes. You can draw like this. Okay, you draw it by yourself. Draw 3 cm, 3 Newton, 3 cm. You draw upwards. Then after that, I want we maintain 3 Newton. We move the 4 Newton to be here. Continue. One force followed by another force. So this one 3 Newton followed by your 4 Newton here. I want the ruler. Where is my ruler? I seldom using ruler, so I also hard to find. Oh, here. Okay, for example, you draw 3 Newton with 3 cm. 3 Newton with 3 cm. Okay, 1, 2, 3. Okay, something like this. Erase. Okay, here. 1, 2, 3. Okay, here. This is the 3 Newton, dear. 3 Newton. Direction cannot change, So I move the 4 Newton upwards. So we move the 4 Newton upwards. Move your 4 Newton upwards. So you draw 1, 2, 3, 4. Something like this. Okay, you know how to using your ruler, even though you didn't using protractor, your 90 degree, you also can draw your 90 degree. You see how I put my ruler and my scales, my line. You see my ruler scales is parallel or in line. Okay, in line. So this one confirm is 90 degree. Here, confirm 90 degree. Okay, then after that, we draw this. Okay, this one is 4 Newton, which is 4 cm to represent it. This one is 3 Newton that I drawing 3 cm to represent it. Okay, as I told you, what is your resultant force? Your starting to ending. So this is my starting. Here is my ending. Starting. Here is ending. Okay, then you move your ruler. Okay, move your ruler. Move, move, move. Okay, can you see my ruler? How many cm? 0 to 5 cm. Can you see? This is my resultant force. So no matter what method I use, this one 5 Newton because it's measuring 5 cm. Okay, no matter which one I use. Okay, at the end I will getting the 5 Newton, same answer. So I repeat one more time. Okay, when we want to draw vector diagram, we got some rules. What is our rules? Tip to tail rules. Your arrow, okay, tip. Here is your tip, followed by the tail of your arrow. So I can say one force, then you continue by another force. So how we do this? You maintain one of the force, you move another force. Then this is your starting, ending. At the end, you see these two, they are represent your resultant force. Okay, so this one is actually in our syllabus. You need to know how to draw. Okay, then after that, they might be asking you to measure the angle. Okay, they will tell you which angle they want. Either is here, resultant force to the horizontal force, or resultant force to the vertical force. So how we measure? Using your protractor. Just now 90 degree, if you don't want to using protractor, doesn't matter. But right now, if you want to measure this angle, then you have to using protractor. Okay? Next, this is the only way for us to do calculation and get the answer? My answer is no. We can also using a mathematic way to solve this problem, which is 90 degree. So you can using Pythagoras theorem. As long as the question doesn't mention, please use scale diagram or please use vector diagram, that means that we can choose. We can use either mathematic way or physics way to solve it. If they didn't mention, then this is the most easiest method lah. Okay? Pythagoras theorem, you see, 4 Newton, 3 Newton. Do you know A, B, C? A square equals A square plus B square equals to C square. This is Pythagoras theorem. So how I know the C? Okay, this one I write it here. This one mathematics A, B, C. C square actually is A square plus B square mathematics. So C is equals to A square plus B square, then we square root it. So in this case is 4 square plus 3 square, then we square root it. So my answer is 5 Newton. It's exactly same like what I draw just now and the answer that I get. Okay, so at here, teacher, what is the angle? Okay, can you please label this is the angle that I calculate? Okay, do you know Tua Kaso? If you are Malaysian, your teacher teaching you, this should be telling you Tua Kaso. That means that the auntie, aso is auntie lah. Tua Ka, that means that big leg lah, okay? Tua, so is tangent equals to your opposite divided by your adjacent. Okay, so this angle opposite is 3 Newton. So it's 3 no? Over your adjacent. Adjacent is 4, near to your angle. So 3 over 4. Do you know how to press your calculator for this? So when you're finding that delta, the angle should be inverse tangent 3 over 4. So if you take out your calculator, because I realized that some of my students, they don't know how to press calculator for this part. They're asking me how to get the 37 degree. So boys and girls, you press your shift, press your tangent. In bracket, you key 3 over 4. Then you will get the answer 37 degree. Okay? Is it okay, dear? Okay, just now if drawing diagram here, you also can using your protractor measure. Is it this angle is roughly equals to the 37? Okay, because drawing sometimes we accept plus minus. So the angle maybe is 36, 37, and 38. So it's normal. But if you're using mathematic way, that is the only answer we accept, 5 Newton and 37. But if you're using vector diagram, we might be accept 4 point something Newton, 5 Newton, and 5 point something Newton. We can accept plus minus. Okay, so this is the example. So with this example, I want we go to the practice first. Okay, instead of keep on talking about the theory, I want to go to the page number. Can you go to your page number 7? We go to page number 7 and we practice. After we learn, then we practice. Okay, you see, this is two forces acting on the different balloon. On a different balloon as it move. Okay. Direction acting on. Okay, here, boys and girls. This question, this past year question is 2023. It doesn't say that you must using vector diagram or you must using calculation. So for this question, we can solve it either one. Okay, either method, doesn't matter. Okay, here, first thing, you must be very clear. One force pulling in this direction, where the balloon will go? It will go at the middle. So this is the direction later on you should draw. So later on, your direction should be somewhere here. This is your direction of your resultant force. Okay, can you, I leave the space at here like this, is because I want you try to learn about vector diagram and also calculation. Okay, can you try by yourself? Draw out the vector diagram. Okay, first you set 1 cm represent how many Newton? Any of you can type in your chat box, tell me 1 cm represent how many Newton? You think is good? To represent 0.4 and 0.74. Any of you can tell me what is the suitable scale? No idea? Any of you? What is the scale? None of you? 0.2. 子花 0.1. Teresa 0.2. Okay, dear, if you're using 0.2, your 0.4 only draw 2 cm. You think 2 cm is good? I agree with Zihua. We're using 0.1 is better. If you take out your calculator and ruler, you will find that 0.2 is so small, dear. 0.2 is so small. That means that your triangle will be very small. So 0.2 is not a good idea. Okay, here, can you try? You can have two ways to solve the problem. One is, okay, you stay, case 1, okay, case 1. We stay, we stay, let me think, we stay 0.74 Newton. Then move 0.40 Newton. Case 2, we stay 0.4 Newton, then move 0.74 Newton. Okay, can you try before I give you the answer? Can you try and then you tell me what is your resultant force? Try. Take out your pencil. First, you stare 0.74. So this one you draw 7.4 cm. Draw it downwards. Then you move 0.4 after 0.7. Then you continue by 0.4. So what is your resultant force? Measure. And then you tell me. I will show you the answer. But I want you to try first. Those have no idea? You can roughly have a look, but don't always copy. So remain 0.74 Newton, then continue 0.4 Newton. 0.74 Newton, you draw with the 7.4 cm. Then 0.4, you draw 4 cm. And then you tell me what is your resultant force. Teresa, good job. Teresa, you can try with another one. Case 1, case 2. Between 0.85, huh? Between? Let me have a look. 0.85, okay lah. Because for drawing, we accept plus minus. So okay, it's fine. Okay, here, boys and girls. How about others? Did you able to get the answer? Zero point 0.85 Newton. Oh, yes, no problem. Plus minus we accept. But for calculation part, no. Calculation is accurate, must be the exact answer. Okay, so boys and girls, if you draw it properly, you will be roughly getting answer like 0.4, 0.5. Let me have a look. This is 2023. Let me check the answer scheme. What is the range they accept? The rest of you continue your drawing. Then I show you, and let me have a look. 2023 November 42. Okay. So boys and girls, here this is my answer. Okay. Either one method, both will give you the same answer. Both will give you the same answer. And can you see that? Basically, no matter which method I use, I will getting the same resultant force. I will getting the same resultant force. Okay, I want you have a look here. Relative relations, direction relative to horizontal force. Where is the horizontal? This is your horizontal. What angle they want? They want the resultant force until the horizontal. So can you using a protractor and measure this angle? Okay, measure it. What is the angle that you get? If you do it correctly, your answer should be roughly 62 degree. So this one should be 62 degree. If they say direction relative to vertical force, that means they want this angle. Always from resultant to the force they want. Okay? So boys and girls, this is called drawing, vector diagram. But how about calculation? Calculation will be much more easier. So how you find resultant force? Can you using your Pythagoras theorem do calculation? 0.4 square plus 0.74 square. Calculate what is your resultant force. Then what is your angle? Angle using trigonometry. So ask yourself, angle. Just now I told you tua, so tua. So opposite of the angle is, opposite to the angle is 0.74 divided by adjacent 0.4. So do your calculation. What is your angle? Do you able to get 62 degree? So here I showing you two methods to solve the question. Both method, either method doesn't matter as long as you get the answer. Now, the most important is this question they didn't specify what method you use. So you can choose either one. Okay? So at here, your answer should be 8.4. Okay? Angle should be 62 degree. Now, I want you, question number 7. Without guiding, can you try question number 7? And then you tell me what is your resultant speed? And resultant, what is your resultant speed and your angle? Okay, your angle. And then this question, next question, question number 7, they specific, they want you draw a vector diagram to find the resultant velocity. So you cannot using calculation part. You cannot using mathematics to solve it. Okay, so at here, this question, they say draw a vector diagram. So you only have one method to solve this problem. Can you try it? Try it and then you type your answer on the chat box. Let me check. Airborne is flying towards to the east. Okay, where is your east? This is north. Here is east. So that means that it will be going here 92 meter per second. A wind start to blow at towards north. North is going up. North is going up. So the north at here is 24 meter per second. So you're trying to solve it by using these two information they're giving. Okay, draw the vector diagram. Do it right now to find your resultant velocity. So just now the question, if any of you haven't get it, so here is my working step. You can print screen and then later on you study again. Just now is question number 6, huh? Now I want you to try question number 7. Draw your vector diagram. And then tell me what is your resultant velocity. They give you scale some more. They tell you 1 cm to represent 10 meter per second. Not bad. Xuan, what is the magnitude? Magnitude is the value, like 0.84 Newton is the magnitude. Number. Okay. Very good, Zihua. Yes. Zihua, what is the angle? No, your answer is perfect. Good. Xuan, is it okay? For example, just now question 6, 0.84 Newton is the magnitude. So here, what is the magnitude? 0.84 Newton. Xuan, is it okay, Xuan? Okay. Teresa, is it okay, Teresa? Teresa, question number 7. Complete it and then tell me what is your answer. Yes, very good, Zihua. Perfect answer. Okay, Teresa, I'm waiting for you. Dear, so how many meter per second? Your 9.6 is in meter per second or in cm, dear? Have to give the final answer in meter per second. I mean, Teresa, 9.6 represent what? Meter per second or represent your cm? So, yes, correct. Okay, dear, let us check the answer. This is my drawing. Okay, my drawing. So I measure and I get 9.5 cm. But of course, I told you already, they can accept with certain range. So at here, they accept 94 to 96 meter per second. Then if you do calculation, you'll find that the perfect answer is 95 meter per second. That's why just now I say Zihua answer is very good. It's very accurate drawing. Okay. calculation part, it will giving you 95 meter per second. If your drawing can get 95 meter per second, that means that you draw it perfectly lah. But of course, we still accept if you are 94 to 96. So Teresa answer is acceptable. Okay, can you measure what is the angle? What angle they want actually here? Angle between resultant and is the direction. Okay, east. Where is your east? Okay, this is your east direction. So resultant to the east. You measure here. What is your angle? If your angle that you measure is between this range, the answer will be accept. 15 degrees is perfect. So this one, of course, our projector cannot measure point something what. So we accept like 14 to 15, no? According to this, I accept 14 to 15. 14 to 15. Our protractor we got able to measure 0.1. Okay? So for this question, any of you got any question want to ask? Okay, you see, the only answer can be shown is this vector diagram. But we don't know we draw correctly or not. We can use calculation to check answer only. Because this question one vector diagram. This is just for me to check answer. Okay, until here, any question? If no question, can you give me some reaction so I know that we can proceed? Can we proceed? Teresa, okay. Wei-Tong, okay. Crystal, okay. Megan, okay. Roshan, okay. Zihua, okay. Emily, okay. Okay. Licious, Licious. Licious, is it okay? Able to get the answer? Can or not, Licious? No, which part, like dear? Oh, just now you are the last one join our meeting, join our tuition. Which part you facing problem, dear? The FR is resultant force, is it? So we need one force followed by another force. So the what? U. What is that? Which part you facing problem? These two can or not? These two? Is it okay for you? These two? So here is my starting of my force. Here is my ending of my force. Okay, starting to ending, this is my resultant force. So we just using our ruler, connect the 2 points, we measure it, and I get 9.5 cm. 1 cm represent 10 meter per second. So, sorry, this is 95, this is 95. Not 9.5, it's 95 meter per second. It's just I don't know which part you facing problem. Can you tell me? Or maybe later on you WhatsApp me. Maybe later on, if which part you cannot, then you WhatsApp me, then I explain to you. Okay, boys and girls, here, continue this part. Okay, dear, Y resultant force is an example of vector quantity. Why? Any of you can tell me why resultant force is a example of vector quantity? Type your answer in the chat box. Let me know, right, dear? Or I need to call your name to answer me. Why the resultant force is an example of vector quantity. Starting of the lesson, I got mentioned. Why force is vector quantity? Okay, Crystal. Luckily, Crystal answer me. Because it has direction. Yes, it has direction. If scalar quantity is only magnitude, no direction. Because resultant has a magnitude and direction. Yes, it has direction as well as magnitude. Okay, if scalar quantity, only magnitude. Vector is magnitude and also direction. Okay, Can you give an example of vector quantity others than force? Because we already know force is vector. Acceleration, very good. What else? Any others answer? It got a lot of answer. Velocity, very good. What else? Velocity is what divided by time? Very good. Displacement. Okay, one more. Last week or last week we will learn momentum. Impulse. Impulsive force. Of course, impulsive force is one type of force. So no. Impulse, yes. Okay, all these we need to consider direction. They are vector quantity. Okay, so boys and girls, then we go back to our question, page number 5 and page number 3. Okay, so for the 90-degree already done, 90-degree already done. Basically, this is our syllabus, our syllabus. Okay, this one is why I still need to teach about non-perpendicular force. They are non-parallel and somehow they are not 90-degree. How we solve it? I still need to teach you is because we avoid it come out in MCQ. Okay, it doesn't have a very clear instruction say that this one is removed. It doesn't mentioning anything. So we learn a bit like, okay, assume it's extra knowledge for us, but actually not hard. It's same like just now what we did. You see, we look at the triangle of forces first. Okay, triangle of forces. So for example, there is two forces pulling. Where are you going? In between them. This is your resultant. This is your resultant. So how we solve this? Actually using the same method as what we did just now, tip to tail method. So I remain the F1. I move my F2, continue one force, followed by another force. Here is my starting, here is my ending. So I draw my starting to ending. This is my resultant force. Exactly same like what we draw just now, but just now is 90-degree. Now with certain angle, that's all. That is the difference. It's the same method. Okay, we might be say, teacher, then I don't want to move F1. I don't want to maintain F1. I stay the F2. Can or not? Yes. Okay, for example, we draw the F2. Okay, I move F1 after followed by F2. After F2, I continue my F1. Okay, I continue my F1. What is my resultant force? My resultant force will be the starting to the ending, this part. This is my resultant force. Am I right? So can you see that, dear? Can you see that? This resultant force is same as this resultant force. This is what we did just now, but just now our drawing is with 90-degree. Now with a certain angle, not 90-degree anymore. Okay, so this method actually is the same. Same like just now. Okay, when I combine these two triangles, make it together, actually it's called parallelogram. You see this triangle? Okay, you see this triangle? It's just now the triangle that show on your worksheet. Then the upper part, this triangle, actually is what I draw. I stay the F2, I move the F1. I combine these two triangle, actually the method called parallelogram. How this parallelogram is working? Okay, we don't need to move these two. They are starting from the same point O. Okay, they start from the same point here, O. Okay, I know that their resultant force is in between them. But which direction I should draw and how far I should draw? Okay, we draw the parallel line. This line, F1. Let's say F1 is 3 cm. Then I go up my ruler here, I also drawing 3 cm. Here, let's say it's 5 cm. I move here, I draw 5 cm. Can you see parallelogram, parallel? So I draw these two line parallel line. I draw these two parallel line. So this is my starting O, S. Here is their ending and their intersect point. So in between, I draw connect the line. This is my resultant force. No matter you are using parallelogram method or tail to tip method, you will get the same answer. Because parallelogram basically is come from the tail to tip method, tip to tail or tail to tip method. Okay, so this one, So far from 2023 until right now, it's not coming out. In the syllabus, it doesn't really clearly mentioning, say that this one is out of the syllabus. So we learn a bit. Since it's not that hard also, so we learn a bit. Okay, by the way, here, come here, our IGCSE 2024, last year past question. They said that I got two force, F1 and F2. They are at right angle. So dear, right angle meaning what? 90 degree to each others. How you find your resultant force? Mathematic way. A, B, C, D. What is your correct answer to find resultant force? Zihua correct. Let me have a look. Megan. Correct. Megan correct. Crystal correct. So dear, our answer will be A. Pythagoras theorem. Okay, Pythagoras. Teresa, yes. So this method easy run. Okay, here. Now, I got a board start moving U and V in this direction. Can you find out which vector diagram is represent your resultant velocity? Can you try and then tell me A, B, C, D, which one is the correct answer? Megan, no, Megan, one force followed by another force. One force U, then you continue draw your V, but they are one force followed by another force, tip to tail. Tip followed by another force tail. Krista, be careful with the direction of resultant force. Emily, correct. We don't know. We don't be careful with the direction of resultant force. Crystal, correct. Zihua, correct. Teresa and Xuan, correct. Okay, boys and girls, our answer will be C. Okay, first, remember, one force followed by another force. So for your A here, you see this one. They are not tail to tip, tip to tail or tail to tip. They are no. They are didn't follow one force, then followed by another. So A and B, actually, this part is already wrong. They cannot connect in this way. They must be one force followed by another one. So tip connect to the tail. Okay, C and D. Why D is wrong is because this is our starting of our velocity. This is our ending. So your resultant force should be in this direction. So D is wrong. Answer is C. Okay, answer is C. Okay, boys and girls, can you try question number 3 again? 2023. Which vector diagram correctly show the force Z as the resultant force of X and Y? Okay, here. A, B, C, D. Which one is the correct way to show you force Z actually is your resultant force? Crystal, same problems. Is it tail to tip? Your X and Y, is it tail to tip? Correct. Second one correct. Zihua correct. Teresa correct. Good job, Teresa. Okay, let me check. Hui Teng correct. So boys and girls, your answer at here should be donkey. You know why it's donkey? Tail to tip method. Tip to tail or tail to tip doesn't matter. Okay. So can you see that these two, they are not follow our rules. Tip to tail. No. Okay. So this one also wrong. It doesn't follow. Then this one C, this one here correct. But this is our starting what? Starting of our arrow. So this is our ending what? Direction should be go from starting to ending. So our answer should be donkey. This one is wrong. Get it? Can we proceed to the next page? Give me reaction so I know that we can go to page 5. Okay, Okay, then we go to your page number 5. Okay, which diagram show the resultant of these two forces? There is P and Q acting on the object. But this question is not a parallel, it's not a perpendicular, it's some with certain angle. A, B, C, D, which one is correct? If they're using parallelogram, which one is correct? If they are using the triangle of method, which one is the correct? Correct, Crystal. Yes, good job. Teresa, good job. You understand about this topic. How about others? Y10 correct. Megan correct. Zihua no? Zihua no? Okay, so boys and girls answer is C. Okay, answer yes, Zihua right now correct. You see, if this method is, they are using parallelogram. You see, parallel, then parallelogram. So this is correct. Okay, this one D is wrong is because this direction, it should be go outward. From here, go out. Okay, this one B, why B is wrong? Is B doesn't follow the tips to tails. So it doesn't follow the tip to tail method. Okay, if triangle, follow tip to tail. If not triangle, then it might be a parallelogram. Okay, so boys and girls, number 4. What is the resultant force for this? Okay, teacher, now we got 3 force. How to do? My hint is, can you solve the parallel one first? 1 Newton and 9 Newton, they are acting in opposite direction. So what is your resultant force for horizontal part? Then, from there, you solve. Continue solving. No need to using the what? Vector diagram. You're just using the Pythagoras theorem lah. 9 Newton, 1 Newton is opposite to it. So it should be 8 Newton. From here, do you able to solve it? What is your resultant force? Correct, Zihua, correct. How about others? This one easy. This one is just 90 degree. How you solve 90 degree vector? Emily correct. Teresa correct. Answer should be B, dear. Answer should be B. So your resultant force should be in between them, somewhere here. You imagine you're standing here, 2 forces pulling you. You are going to the in between them. So your resultant force should be square root 6 square plus x square. 10 Newton. Okay? We go to your page number 6. Is it okay? Give me a reaction, then we go to page number 6. Crystal okay, Xuan okay, Megan okay. Only 3. Teresa okay. Wei-Tong okay. Zihua should be okay, Wei-Tong okay. Okay, right there. Number 5. A ball of weight. Weight is 1.2 Newton. So weight always pointing downward. So I know 1.2 Newton pointing downward. It dropped through the air at terminal velocity. Still remember this topic we learned it before. When terminal velocity, what is happening? That means constant speed lah. Okay, constant velocity. When constant velocity, your resultant force is 0. So when we can achieve the constant velocity, when your weight is equals to your air resistance. Do you agree? Recall back terminal velocity the topic. Okay, so boys and girls, from this sentence, they don't tell you that air resistance, but they're using this word at terminal velocity. Okay, they experience air resistance in the terminal velocity. So from here, I know that I will having another 1.2 Newton upward due to the air resistance. Okay, suddenly we got the wind exert a horizontal force 0.5 Newton on the ball from the left. Okay, which diagram should be your resultant force? Okay, so boys and girls choose. Emily, good job. Yes, Emily, your answer is correct. Where is your what is your vector diagram and which direction is your resultant force? How about others? Only Emily tell me the answer. How about others? Let me have a look about Megan. Megan, correct. Kristen, no. Kristen, no. Kristen, no. Kristen, where is your air resistance? You forget about your air resistance. Teresa, no. Teresa, no. Where is your weight, Teresa? Zihua, correct. So boys and girls, your answer should be C. Why? You see, just now we read from the first sentence. It's already tell you we got the weight. So you will have the weight. So this is your weight. Okay, then they say that it dropped and passed through the air at terminal velocity. Because of terminal velocity, this word, I know that my weight must be equal to the air resistance that we experience. So that means that I'm not only having the weight, but I also having my air resistance. So this one is my air resistance. Here is my weight. Okay? Then the wind blowing 0.5 Newton from the left. So this is the vector diagram. And then which direction is your resultant force? So can you see this? 1.2 upward and downward 1.2. So that means that the vertical part is cancelled already. It can be cancelled out, vertical part. So no more vertical part. The only force, resultant force is this direction. That's why you see the resultant force is in this 0.5 Newton. It's because the air and the weight, they balance each others. So I think if you cannot solve this question, it's because you forget about this knowledge, terminal velocity. Okay, is it okay, dear? Okay. So we goes to your last page, page number 9. The rest we already solved. We comes to page number 9. Okay, just now what we learned is about. I did not saw the bottom part of the part C. Oh, okay. Just now the question, but you solved already. Okay, here, condition for equivalent. Okay, let's say just now what we learned. For example, two force, 3 Newton and 4 Newton. What is your resultant force? Supposedly this object will go in this direction with 5 Newton. Am I right? So it will move. But if this question is talking about like stay horizontally, not moving, hanging, okay, that means that it's a balanced condition, equilibrium condition. So like this, supposedly there is a 5 Newton pulling because of the 3 Newton and 4 Newton. So right now, in order to balance, they will have a third force pulling in the opposite direction and with the same magnitude with 5 Newton. So in this case, you see we got three forces. If these three forces, we draw the vector diagram and we found out that it's able to form a cross triangle. And then these three direction you cannot change. You see this one goes to the right, so goes to the right. 3 Newton go up, so this one go up. 5 Newtons goes to the left bottom part. Okay, so if you able to form them across path, that means these three forces, they are in equilibrium. Okay, we look at this. This diagram is 2024. Okay, so we hang, okay, drawbridge. So it's attached to the wall, and then the weight, okay, this is the weight. We got weight, one of the force. We got the tension. In order, these two forces is showing, but there is a third force to balance it on the hinge. There is one more force to balance these two. Which is the possible direction for the third force? So how I know? I need to form them in a closed path. So can you try? When you go down, let's say you go down. Then after that, another one you follow by another one is going up. Something like this, going tension, going up. So you have to think, what is your third force to close it? A, B, C, D. Correct, Crystal. Correct, Crystal. How about others? Correct, Zihua. Emily, no. Emily, no. You, Emily, you see, these three forces, they are follow one by one. They are different with just now what resultant force with that we count just now. Yes, Emily, correct right now. Correct. So boys and girls, Teresa and Megan are correct. So boys and girls, in order to make it closer, so I should go down, go up, and then here, continue. This should be my third force. So our answer should be donkey. Okay? This is our answer. So boys and girls, this is what we are learning today about the vector diagram. And then the last part, equilibrium, is seldom asking, but it come out last year. That's why I still teaching you lah. Okay? When they want to say that equilibrium, you highlight this one, equilibrium. So you need to form these three, join together to form a closed path. If they're able to form a closed path, that is balance force. Okay, the force is balanced. Okay, if no question, we goes to lesson 11. Is it okay? Okay, Crystal, okay, Megan, okay. How about others? Okay, let's go. Okay, we comes to here. Equation of motion. Actually, if you're using same textbook as me, you'll find out that what I am going to teach today is not in the syllabus. Okay, but this one is very important. That's why I decided to teach. Is because if you don't have this knowledge, when you solve the question IGCSE, you will very limited to solve, very limited method to solve the question. You're facing some problems, okay? And then some more, I'm teaching A level. A level, we will using this all knowledge, and we assume that actually you learned this before. That's why I only 4 pages, very easy to teach you how to applying this 4 formula. Okay, here we need to know the symbol. S represent distance or displacement. Time is t. U is initial velocity, final velocity is v, acceleration is a. All these we learned it before. Okay, here, linear motion, we need to divide it into 2 cases. We ask ourselves, right now, the velocity or speed, are they constant all the time? If constant, then we just using distance divided by time, settle. If this is not a constant velocity, that means that it might be accelerate or decelerate. If velocity is changes, velocity is changes, u not equals to v, is changes. So we are going to using these 4 equation. First equation actually is easy, no need to memorize. It's because a equals to v minus u over t. It come from here and rearrange only. Okay, rearrange only. Then here the another 3 formula, later on we'll learn and choose how we choose this. Okay, but before I start, here got empty space. I want to write something and you take note together with me. Okay, case 1. If the object is drop something. Okay, so you write down. If we drop something, okay, first, I holding something at here, my ruler. I open my hand and I release. Do I need to special give any initial velocity to let the object to drop? My answer is no need. In the case of dropping, my initial velocity actually can be 0. I just open my finger, the object will drop. No need to purposely give some initial velocity. So when they say drop something, they assume you understand that initial velocity is 0. What information we know? Acceleration. Object dropping, it will increasing speed from time to time. It will accelerate because our gravity pulling. How fast is accelerate? 9.8 meter per second square. This is a positive value is because increasing speed. Speed increasing. Gravity pulling it. Gravity. Okay, these 2 information will not be informed you by the question. They assume you know it by yourself. Okay, so this is case 1. We go to case 2. Okay, we throw something upwards. Throw something upwards. Okay, I draw something upward. Okay, first question. I put my ruler or eraser on my hand. If I didn't give any initial velocity, will the object moving upward by itself? My answer is no. So for this case, we don't know the initial velocity. It must give some value for initial velocity. But what information we can know? We can know that when object move to the maximum height, maximum height. So I want you holding your eraser and then you throw. Observe. When you throw, what happens when they goes to maximum height? Your speed from starting to ending, actually your speed is increasing or actually your speed decreasing until the maximum height. What do you think? We throw something upward is we against gravity. Agree or not? We against gravity. When you throw something upward, you are against gravity, so your speed should be slowed down. Your acceleration 9.8 meter per second square actually is slow down. When it slow down, we need to put a negative. It's because negative is represent velocity slow down, decreases. Against gravity, we against gravity. So boys and girls, why the object goes to the maximum height? After maximum height, what's going on? It fall down again. Am I right? You throw something, it will go up until a certain moment, it will go down again. So when it goes to the maximum height, what is your velocity when it goes to the maximum height? What is the velocity when it goes to maximum height? Then after that, it fall down again. What is your maximum height? Velocity and maximum height. My answer is 0. It will decreasing the velocity until the speed or velocity becomes 0. Then the object will be pulled by gravity going down. Okay, so at here, boys and girls, we got 2 information you have to know. At maximum height, your velocity is 0. Throw upward, your acceleration should be negative 9.8 meter per second square. Okay, for these 2 cases, any of you got any question you want to ask me? Before we proceed to the question and try. So for the job, these 2 information we have to know. Why is acceleration is negative? Okay, negative acceleration means that decelerate. Teresa, decelerate. Decelerate means what? Slow down. When you throw something upward, it against with your gravity pulling. So actually, object will slow down. Slow down until maximum height. It don't have any speed. It will fall down again. So why negative is because velocity slow down is deceleration. Why deceleration? Because we against gravity. Is it okay, Teresa? Okay, if you clear about these 2 cases, we are trying to apply it on our past year question. Okay, we comes to this past year question. First past year question, a man stand at here, okay, standing. So the train is past the man, okay? Train moving with 40 meter per second. It takes 2 seconds to pass through the man. Can I ask you the velocity for the train keep on changing or all the time is constant? What formula you should use to solve this question? Velocity, did it change? For the train to change, will it change? Okay. Change or not change, dear? No change. No change. That means that we are using this one, the most simple one with constant velocity. So we're using distance divided by time. So boys and girls at here, our speed is equals to distance divided by time. Your speed is 40, your distance, and your time is 2. That means that to complete the whole path, actually is the length of the train. It's 80 meter. So your answer should be donkey. Most important is the train doesn't change velocity. The train doesn't change velocity. Okay, now we goes to question number 2. Something is happening here. Okay, a stone is released from the rest. So at here, from a high building. So this is a high building. Okay, object is released. From rest, that means that starting is 0. From, that means starting, velocity is 0. So U equals to 0. Air resistance, we don't care about air resistance. What is the velocity? When it has fallen 5 meter. Okay, let's say fallen 5 meter. What is the velocity at here? What is your V? Okay, here 5 meter actually is your distance. So it's S. We need one more information. We need one more information. I got the U. I got the S. What is your A? Your A is positive or negative? What do you think? Your A is positive or negative when object falling? Positive. 9.8 meter per second. Why? We drop something downward, it will increasing the speed. Gravity pulling and make it increasing the speed. Okay, so boys and girls, just now for formula, V equals to U plus AT, S equals to 1 over 2 U plus V times T, S equals to UT plus 1 over 2 AT square, V square equals to U square plus 2AS. Okay, like boys and girls, what formula we use? You look at here, UAVS, UAVS, UAV. I don't have S, no. U, no A, no. U, A, V, no V, no. U, A, V, S. Last one is the formula that we use. V square equals to U square plus 2AS. Can you help me to solve and find out what is your V? Do it right now and then tell me. Crystal, correct. How about others? Do you able to get the answer? Huiton, correct. Roshan, correct. Shuan, correct. Who else? Okay, answer should be B. Okay, answer should be B. Zihua, no. B, yes. Okay, so dear, this question settle. We look at the question number 3. We projected vertically upward. Now the case is upward. Okay, with initial speed, they tell you initial speed is 15 meter per second. We ignore air resistance. What is the maximum height? Okay, here, this is the maximum height. What is the maximum height? That means that what is your distance it can be traveled. Okay, how far it can travel or go up. Okay, here, I only got you. So you need to have another 2 more information. They don't tell you, but we have to know. At maximum height, your velocity, final velocity should be 0. It's because object going upward, at a certain moment, it will go down again. Why it go down? Because when it goes to the maximum height, velocity becomes 0, then gravity pull it, it will fall down again. So your acceleration at here, against gravity, an object will decelerate. So I need to put a negative. Okay, can you try? What formula you should use to solve this question? You have SVAU. SVAU. So what formula you should use? Hui Tong correct. Hui Tong already get the answer. How about others? Any of you? Question number 3. What formula you use? What is the final answer you get? Emily, Emily? Teresa correct. Teresa correct. Emily correct. Okay, so boys and girls, we use v square equals to u square plus 2as. Zihua, did you get the answer? Do you able to get the answer?
Is it B?
Yes, correct, dear. Okay, answer is B. So this one final is 0 square equals to u 15 square plus 2a is negative 9.8. S we don't know. So 2 times 9.8 S equals to 15 square. Using a mathematics you solve, you should get 11 meter. So answer is B. Okay, we go to your page number 3. Any question? If no question, give me response. Then we go to page 3. Is it okay? Okay, let's go. Okay, here. A ball is thrown vertically down. Oh, throw. They are not from rest, they throw. So they give initial velocity, u. So they throw it downward and they give initial velocity, 4.23 meter per second. The ball takes 1.51 second before hitting to the ground. Ignore the air resistance. Can you show that the downward velocity when it hit? That means that they want to know V is, what is V? Can you show that you're able to get V is 19 meter per second? Okay, this question, we still need one more information. I don't tell you. A is equals to what meter per second squared? Can you try? Just now the 4 formula, which formula is suitable for you to find out what is your V? Do you able to get V is equals to 19 meter per second and prove it? Prove that you're able to get V is 19 meter per second. Correct. So why you don't have calculator? Oh, yeah, because this one is proof. Yeah, Zihua get the answer. How about others? Did you able to get the answer? UVAT. What formula you use? UVAT. Correct, Hui Tong. V equals to U plus AT. V is we don't know. U is 4.23 plus 9.8 is the acceleration. Positive, because this is going down, accelerate. Time is 1.51. So your answer should be get 19 meter per second. Is it okay? Can you try calculate to 3 significant figure the distance? How far S? Can you try? What is your S? For the ball falls to the ground. Tell me your answer.
Teacher, For
What
this
is
one, our velocity we use 19.0 meter per second or 19.028.
okay? This is the problem, so I wish you do not using this V. So UATS, can you using UATS to solve? More easier. If you're using V, you will get almost the same answer. You can 19.02 or 19. What just now that you get, no problem. But if let's say this question A, you calculate wrongly, you carry the wrong answer to the B. So the whole part for B, you might be unable to score any marks. So that will be a bit dangerous. I'm trying to ask you to use U18. This three is confirmed, plus the S to solve the problem. If you want to involve with V, that is for you to check answer. That is my answer. That is my advice. Return, correct. Return, what formula you use? 1, 2, 3, 4. Which one? Okay. So boys and girls, as what I mentioned, U is equals to 4.23 meter per second. A confirm 9.8 meter per second square. Time also confirm 1.51 second. Then we want to find S. What formula? S equals to UT plus 1 over 2 AT squared. So answer should be 4.23 times 1.51 plus 1 over 2, 9.8 times T squared, 1.51 squared. Answer at here should be 17.6 meter. Three significant figure. 1, 2, 3. Three significant figure. Okay, like what Zihua asking just now, if I want to using V, okay, V. So Zihua, initially what formula you use for to apply the V? First, second, third, or fourth? Initially you using the V.
S equal to 1 over 2 U plus VT.
Okay, U plus V times T. Is it okay or not, teacher, for us to use this formula? My answer is yes. Yes, but please make sure your A answer is correct. Okay, 1 over 2. Your U is 4.23 plus the V at here. My concern is because the V is calculated by you. If just now they didn't tell you at here your V is 19, this value will be calculated by you. So if this answer from the A you do it wrongly, then you carry forward the wrong answer to the B, your B will lose the mark. So at here 1.51. So is it you get also the same 17.6 meters? Mm.
In the end, I changed to the other formula.
Oh, you change to another formula. This
Yeah.
one should be able to get 17.6 or 17.5 meter lah. Both answer in answer scheme can be accepted. Either one. Either one. So you can using a lot of formula for you to solve. A lot of formula for you to solve. My advice is we trying to choose those information that confirm. Trying that not involved with what you calculate just now. In case in your A here you do it wrongly, then you carry the wrong answer to the second question B. Is it
Yeah, I
okay?
calculate already. The answer is 17.5 if we
Okay. So this one, you see, this one, if you calculate using this, your answer should be 17.5 meter. So in the answer scheme, this answer also acceptable. Okay. So can we go to the last question, page 4? We got another 6 minutes. Okay, page 4. What is the meaning of deceleration? Deceleration actually is negative acceleration. Am I right? Deceleration meaning that negative acceleration. Okay, how we define acceleration? Last time I teach you, acceleration actually is v minus u over t, right? Per unit time. In physics, we got a word called rate, R-A-T-E, meaning per unit time. Rate of what? This is change of velocity. Velocity change, okay? Rate of change of velocity. Okay? Rate of change of speed per unit time. No. Rate is already meaning per unit time. So rate already bring the meaning of per unit time. So you don't per unit time again. Okay, so rate of change of velocity This is represent your acceleration only. Deceleration is what? Negative rate of change of velocity. 2 mark. If you're able to say rate of change of velocity, 1 mark. If you're able to say negative acceleration, 1 mark. So negative rate of change of velocity. This is definition for deceleration. Okay, so boys and girls, this one is what? A ball of mass 130 is launched from the ground with initial velocity. Okay, vertically upward. Initial velocity is 14 meter per second. The acceleration of free fall is 9.8 meter per second square. Show the time it reached to the height. Height is the maximum height at here because it will decelerate until it is rest at height h. That means that the h at here is the maximum height because at the moment here, this is maximum height is because at the moment here is rest momentary. So this is your s distance. So what they say, the time for the time is 1.4 seconds. Show the time. They want you to show the time. Okay, you have to calculate what is your time. Okay, boys and girls at here. Anything you want to correct me? I write all the information, I draw everything based on the question. Anything you want to correct me? There's something I'm waiting for you to correct me. Shouldn't correct. But on my diagram, there is something I'm waiting for you to correct me. But I draw everything, label everything according to... Yes, Zihua. Negative. Although the question say 9.8 meter per second, but here what we're using should be a negative here because I throw upward against gravity. So what formula I can use? U A U V U V A T U V A T. What formula? U V A T. Is it the first formula? V equals to U plus AT. Final is 0, initial is 14 plus negative 9.8 t. Is it your t? You get 1.4 second. If not mistaken. Is it okay? Can or not, dear? If okay, then we go to next question.
Yes.
Yes, Okay, can you help me to calculate what is your h? H is the height, which is the distance traveled, which is your s. As I told you, we're always using the information provided by the question. I know my u is 40 meter per second. I know my final will be 0. I know my acceleration is negative 9.8 meter per second square. I want to find my s. What formula you use and tell me what is your answer. What is your answer, dear? Correct, Zihua. How about others? Did you able to get the answer? We're using the last formula, v square equals to u square plus 2as. V is 0, u is 14 square plus 2n s. So your s at here should be get 10 meter. If you're trying to apply just now the timer inside here for you to do calculation and using others formula to get your s, you will get the same answer. Okay, boys and girls, you will get the same answer. If you're using others formula which involve with T, you'll get the same answer. Okay, for C, any question there? If no question, give me response, then I'm going
Just
to do
now I
D.
used the UT plus 1 over 2 AT square.
VT 1 over 2 AT squared. VT, which one? First,
Wait, wait,
second,
wait,
or
wait.
third?
Yeah, UT plus 1 over 2 AT square for C.
Okay, for C, so this one S, right? Also correct, because here 1.4. 1.4 is the correct answer. What? Correct. So as I told you, you can apply others formula. They will give you the same answer. Okay? Okay, last one. Yeah. But last one actually is talking about the terminal velocity. Object drop, the ball drop. Initially, object drop is because of the weight. How it accelerate? Accelerate exactly at 9.8 meter per second. So this question is talking about the previous lesson that we learned about terminal velocity. Describe and explain the motion. Acceleration is motion. No? Then why? Because it accelerates due to the weight. Okay, so initially the ball accelerates at 9.8 meter per second square due to weight. Okay, so first, after that, when object drawing, we have to consider air resistance. So when it drop, it will start to having air resistance. Here, it will have air resistance. Okay, so your resultant force will decrease. Because I got something against my weight, my resultant force decrease, my acceleration will also decrease. Okay, so at here, second point, air resistance increases with speed. We accelerate, then air resistance will start to increase. So you imagine when you're walking, you cannot feel air resistance. But when you start to run or inside the car, you can feel the strong wind. Actually, that is air resistance. Okay. Then at here, air resistance increase with time. So your resultant force decreases. What is your motion? Your acceleration decreases. Okay, until a certain moment, because air resistance keep on increasing what? The speed. Until a certain moment, air resistance and the weight are balanced. At
Terminal
this moment, your
velocity.
resultant force is 0.
So
Zihua, what do you say?
terminal velocity.
Very good. At this moment, acceleration is no more acceleration. How it moves? Terminal velocity. So in the third case, okay, terminal velocity can be achieved when your air resistance is balanced by the weight. Okay, resultant force at this moment, resultant force is 0. Acceleration is 0 also. Motion is talking about acceleration, 9.8 initially. Then acceleration decreases. At the end, acceleration is 0 and terminal velocity is achieved. Explain. So you need to explain in terms of force. You have to explain based on the weight and based on the air resistance and in terms of their resultant force to explain why why acceleration decreases. This topic, this question, 3 marks, actually we learned it before in the topic about terminal velocity. So if you forget about this, please revise again. Take out the lesson and revise again about this topic, this subtopic. Okay, until here we finish our chapter 3. Next week we will continue our chapter 4. Any question for today's lesson, dear? If no question, that's all for our lesson. Bye bye.